this was 2, this is part 3. Normally we would go and use the formula. The formula is like P minus, or P hat minus P over square root. Do you remember us doing this last time? P Q over N. However, they don't give you enough information to do that. And you might be thinking, well, what do you mean they don't give you enough? They just tell you P. They tell you that P hat is 0.49, and they tell you that sigma is 4.04. So the sigma, like the way your teacher's doing it, that represents everything in the denominator. Like your entire denominator is 0.04. That is how you're able to calculate the test statistic, because you don't have enough information otherwise. So it's 0.49 minus 0.33 over 0.04. So the teacher is trying to simplify the calculation for you to make it easier on you, the student.
Okay.
So you have to calculate this.
Negative 7.76.
Did you put a parentheses around your numerator?
Is it 4?
It is 4, yes. So in our normal curve here, where is 4? Could you just roughly tell me where it is?
It would be to the right of the 0.
Yes. So it's way over here to the right. We'll call that 4. The alternative hypothesis tells you which direction to shade. Do you remember that from the other night?
Yes.
Okay, so the other night we talked about that means you're going to shade to the right of that. Okay. Now it says from the table, but we can do this for with the calculator. Do you remember how to do that?
Not on the calculator.
So that's where you're doing the lower, the upper, the mu, and the sigma. So that's going to be under second distribution, normal CDF.
Okay.
So your lower is 4 because that's your leftmost value. What is the upper in this case?
The upper. I'm not sure.
So how far so it's always there, it's either 10 to the 99 is or minus 10 to the 99. If you don't have one, you're going to use one of these values. We did that a little bit the other night. Do you remember that maybe?
Yes. Why is it 10 to the 99?
Well, this is what I've seen students use over the years. It doesn't need to be that large. It just needs to be large enough. But the calculator, I think, has an upper bound of like 10 to the 99. Like it treats that as infinity, essentially. Like you're going out to infinity, but you can't put infinity in. I mean, it would be better if the calculators had an infinity button and you just put that in there, but you have to know.
Okay. Is it negative 10?
No. Your lower is 4 to 10 to the 99, 0 and 1.
Oh, okay.
Yeah, you've got to put these in. I mean, the second distribution normal CDF.
So it's 10 to the, okay.
Yes, what I'm saying is, like, if you don't know the lower, use minus 10 to the 99. If you don't use the upper, use 10 to the 99.
Okay. And then I got 3.16.
Times 10 to the like minus something.
Minus 5.
Yeah, so that's essentially 0. Like you want you want to treat that as basically 0. Okay. And that's your p-value.
Okay.
So number 4, part 4 here, it says to use an alpha level of 0.25. Let me snip that in. Do you support or reject the null hypothesis? So if you can you look back in your notes and see what this means here? Your p-value is 0, the alpha is 0.25. Do you remember if that's reject or fail to reject?
Yes, let me see.
So here you would reject, because the p-value 0 is less than the alpha level. When you reject the null hypothesis, does that lead to a possible type 1 or type 2 error?
When you reject the null hypothesis, type 1.
Yes. We don't know if it is or not, but that's just something I want you to, have really solidly down. Okay, can you tell me what is on the back side of this page?
The back side of this one is comparing populations, and it's about vinyl records.
Ah, another up-to-date topic. They're making a comeback, but I don't.
Yeah,
I think people. I guess it's pretty good if you have vinyl, but I don't know here. Okay. With the new interest in vinyl records, a company that records and releases classic albums wants to compare the reliability of 2 record fabricating machines. So when you see the word 2, that means it's a 2 something, like 2 sample, 2 proportion. That's a keyword there. Very, very, very important. They randomly select 500 records produced by each machine. The first machine produced 484 records of acceptable quality. The second machine produced 431 records of acceptable quality. So it's kind of like this. And I usually use P1 instead of PA. P1 is 484 out of 500. P2 is 431 out of 500. Now that's not the answer to 1, but that's what you want to glean or take from this information. You got to be able to pull that out of what's going on here in this question. Okay, the purpose of comparing population statistically, we want to know if there is a difference between them. We want to know if one is better than the other or the same or different. We want to know something.
Okay.
Okay, that's they're looking for like one sentence, basically like we want to know if there is a difference in quality between the 2 machines. Something like that would be sufficient. All right, now the teacher asked for this normalcy test. I'm going to suggest you go back and again ask him, but we looked at this at the other one. It's n times p greater than 5, n times 1 minus p greater than 5. You have to do it for both. They will both work in this case. And I can tell because there's more than 5 that are in the that did not pass. There's actually 16 that did not pass. That would be this one. There's 484 that did pass. That's this one. Same thing for P2. There's 431 that did pass. That's the n times p. There's 69 that did not pass. That's the n times 1 minus p.
Okay.
So please ask, please find out what's going to be expected there. Just saying yes is not a good enough answer. You could probably say yes and then write this. Although I might be suspect if I were grading it, it'd be like, does the student really know? But you also know, because they're asking you to do all these other tests, that it does pass. Like you wouldn't do the rest of this if it didn't pass, is another point. This 3 should really say the mean difference in the proportion. I think I might ask, follow up on that. I think it's P1 minus P2. This is the numerator in that equation that I showed you earlier. Let me snip that in again. But I would double check that. So I think it's referring to this one, or sorry, P hat 1, P hat 2. These are hats. Sorry, this should be. Okay, so it's taking the difference between these. It's the 484 over 500 minus the 431 over 500. So whatever that is, that's 53 over 500. And that goes in the numerator, but we're going to use the calculator. So, I don't necessarily need to calculate that. The next one asks for the standard deviation. That's the denominator. So we're looking at this part now, the denominator. So your P hat is where you're adding up the two numerators, 484 plus 431 over 500 plus 500. So will you calculate that for us, please? Round to 3 decimal places.
Um, 501.83.
You gotta put parentheses in the numerator and denominator.
Okay. Oh, 0.915.
Yes. Okay. The number has to be between 0 and 1.
Okay.
So just maybe that goes on a note card there. All right. But that's not the standard deviation. That's just this P hat part. We've got to do all of it because, and the calculator will do the calculation, but there's not a way to get it from putting the numbers in. I don't think. I'll check that in a moment. But we're putting that number into this equation here. So we got the square root 0.915, 1 minus 0.915, 1 over 500 plus 1 over 500, like that. Let me check and see if it will give us what I was asking for. It does not. You have to do it this way.
Okay.
Let me know what you got. You get a number there.
Yes. .0176.
Good. You may want to do the calculations twice on your test tomorrow. There's really not a good way to know if they're reasonable or not, because there's these don't necessarily mean anything to us.
Okay.
All right. So that's 4. Write a 95% confidence interval. So you could do this by hand, but I would just recommend going to the calculator for this. So this is going to be the stat test 2 prop interval. You go double check the spelling on that. Stat test. It's all the way down to 2 prop z interval. So go ahead and enter that in. Your x1 is this 484 over 500 for n1, x2, and n2. Your sea level is 0.95 in this one.
Okay.
Okay, so go ahead and calculate that. Let me know what you come up with.
I got 0.07617 to 0.13583.
So we have a slight difference in hours. Let me see where does your P1 and P2 look like this? 0.968, 0.862.
Yes.
Did you change your confidence interval to 0.95?
It should be. Let me go back. Oh, okay. There we go.
All right, so the confidence interval, you want to write 0.07206 less than 0.13994. And what goes in the middle is from your null hypothesis, which I guess you don't have. So it's P1 minus P2.
Okay.
Now, normally you write a null hypothesis. That's why I said that, because it's really that's the key there. 6 is to write a sentence. That sentence is something like "we are," and then you insert the confidence interval 95% confident that the true proportion difference between, and that's where you got to go back and sort of interpret the language of it, between the 2 machines. So you're comparing between the 2 machines. Between the 2 machines is between, and that's when you give the two numbers that you found in the test there, 0.07206 and 0.13994, like that.
Okay.
All right, so that's everything on that page. So we're going to do well, that was practice 3. Anyway, what's the next page you want us to do?
The one about the mascara.
Okay. Now you may be more of an expert on this than I am. Does it make eyelashes look 5 times longer on average? I don't know. That's a lot here. Okay. So this is a type 1, type 2 situation. You really don't want to get too caught up in, I mean, I'm making a joke here just because it's late and I'm trying to keep it light here, but you want to really just write your null and alternative hypothesis, like, and that helps you to know whether, like, what's the null, what's the claim. And here it's that 5 times. Okay, so the claim would be something like mu equals 5.
Okay.
And the claim, it's kind of hard to interpret because the student in 4th period doesn't believe it. So when you don't believe something, you don't know whether that means it's too large or too small or what it is. So you could just say mu not equal to 5. Okay, but you don't really care about that. What you care about is whether they rejected it or failed to reject it. Okay, so it says here, assume the student erred. Okay, so they think the second one is true, but it's not.
Okay.
Okay, so let me just think about this. Student doesn't believe it. So the student rejected the null hypothesis, like they think that this is true, but it's actually not true. That's the way I'm reading this. You might want to just confirm that with, your notes for someone else's class, but that's the way I'm reading this. Like they said, oh, we're going to reject that. It's 5 times as long, but it's actually true. It actually is true. The company's claim is correct. So when you reject the null hypothesis and it's actually true, that's a type 1 error.
Okay.
Now we've answered B and C and D over and over again, but just reiterate here, to reduce the probability of a type 1 error is to reduce the alpha level. The consequence of the error is that you somehow think you're going to get something different than 5 times as long eyelashes, but you don't. So somehow that's, I don't know if that's good or bad. But you'd want to give a sentence like saying why that's a problem. Like you have to reapply the mascara more often. Or you might buy more mascara because you think you're going to need to apply it more often and you actually don't.
Okay.
And D is always a type 1 error. They're always worse.
Okay.
I'm just looking at the next one here. The instructor uses the same prompt, but what they don't do is they don't really specify in any different way whether they think that the the claim is, you know, whether it should be larger or smaller. And you can't just say, well, because the 3 is less than the 5, that it's smaller. To me, it looks like this is a not equal to situation, like we wrote, like mu is equal to 5, and then mu is not equal to 5.
Okay.
Like there's no language in here that says that we think that the claim is bigger or smaller than that. Sorry for repeating myself. I keep looking for the words that aren't out there. Like I could go grab a problem from the internet and it would have all this information in it to tell us,
Yeah.
but this one does not. So that's your HO, that's your HA. What is the X bar and the sigma for this?
Sigma is 1.2 and X bar is
It's the only other number.
3.
Like you've already used the 5. You already used that one, yeah. And so the X bar has the same like units as the mu. It's another thing to kind of look for. Now they don't specify this, but I guess we're going to assume n is 1 because we don't have any other reasonable thing here. So part 3 is to calculate the test statistic. So the test statistic here, Z, is X bar minus mu over sigma divided by the square root of n. So we got 3 minus 5 over 1.2 divided by the square root of 1, like that.
I don't want to see couple shit in my video games.
Jack.
Is that okay,
Yes.
Julia? Okay. Now you can go to your calculator and also calculate this. And in fact, we need it for the p-value. So you're going to go to stat test, and you're going to choose the you're going to do the Z test.
Okay.
And you're going to use stats because you don't have any data. Data would be like if you actually went out and measured eyelashes in this scenario.
Okay.
If you don't have that, so you got mu 0, you know that number, you know sigma, you know X bar, you know n, and we're going to use the not equal to for mu 0. Let me know what you get for a Z value and a P value.
For Z, I got negative 1.6.
Okay, and for the P value?
And for P, I got 0.095.
Okay, so I did the graph this time. I think it's kind of a useful one. Those are your numbers as well. So the P value here is 0.0956, just like you said. Now we can do part 4. I want you to look at your notes again and decide whether you support or reject the hypothesis based on this P value and the alpha level here. Here we go.
So it's
Do you have an answer for me?
I think you reject it.
So the p-value here, 0.0956 is less than 0.1, so you reject, yes. When you reject, this can lead to a type 1 error.
Okay.
Any questions or any follow-up on that?
No, I think I'm good.
Okay, so the next problem I'm seeing that we have not done is the eyes for the prize, a beauty product.
Yes.
Okay. Let me grab that. We'll look at that. All right, eyes for the prize, a beauty product podcast. Here's about L'Oreal's claim and Estee Lauder's research and compared mascara from each company. From their sampling of 125 eyes, 78 of L'Oreal's product increased lash length 5 times or more. From their sampling of 140 eyes, 90 of Estee Lauder's product increased lash length 5 times or more. That is information. So could you give me P1 and P2 from that information there, please?
Mhm. P1 is 78 over 125,
Good. And P2?
90 over 140.
Very good. All right. Part 3 asks for the mean difference in the population, the mean difference in the population. So let me snip that in. Do you remember what that is from a previous problem, how to calculate that?
A little bit.
It's P1 minus P2.
Oh, okay.
It's just the difference in the two values that you have there. Go ahead and calculate that for me, please, and let me know what you come up with.
Is it negative 0.018?
Yes. Good. Okay. So that's 3. 4 is that part under the square root. Or under the, or in the denominator under that square root. Are you gonna get the formulas or do you have to memorize them? What do you,
Sometimes they're on the test and then sometimes they're not, so I'm not really sure.
okay. Yeah, this one would be hard to do without the formula, so maybe can we get that down? What is this p hat? Do you remember that from an earlier problem? What do we do to find p hat?
To find p hat, oh gosh. That's when you add both of them.
Yes, so it's like how many successes out of how many total? Let me know what you come up with.
Okay. 0.63.
Yes. I'll maybe go out one more decimal place. All right, so that's the square root of 0.634, 1 minus 0.634, 1 over 500 plus 1 over 500. Like that. Gonna go ahead and calculate that for us, please.
Zero point 0.0304.
Yes. Okay. So the way to do part 5, I recommend doing it on the calculator. You could do it with a formula, but we've been doing it in the calculator, so we'll do that again. And because it's 2 proportions, stat, test, 2 proportion z interval. That's what you're looking for. So go ahead and enter the data and let me know if you have any questions.
For p, I got 0.75.
We need the interval, 2 proportions the interval.
It didn't give me the interval.
So make sure you're choosing 2 prop z interval. 2 dash prop z interval. I think it's down in like B.
Oh, okay.
If you use something else, it's going to give you something that, while maybe true, isn't anywhere near what you want.
Yeah. Oh, okay. So the interval is negative 0.17 to 0.13.
Yes. Very good. Now we talked about kind of an important thing here. Is zero in the interval?
Yes.
It is. So that's not good because you fail to reject the null hypothesis. And I know you don't have one here, but that is essentially what you're like. If zero's in the interval, that means there is no difference between them.
Wait, can you repeat that?
If zero's in the interval, there's no difference between the two proportions.
Okay. Okay.
Have we done everything that you wanted to get to tonight?
Yes, we have.
Okay. So some final, maybe some organizational thoughts here. On your calculator, just to be careful here. When you're doing a confidence interval, like we've been doing the last two, it looks like it's you're either using 2-prop z-test for the confidence interval, or the z interval if it's on the mean. But I don't think we did any of those, so I don't think you have to worry about that. To find the p values, we were almost exclusively using the z-test. Okay, but occasionally you had to use the second distribution normal CDF. And that's where you were given a z, you either given or you calculated a z value. And that's when you use the normal CDF, and that's the upper or the lower, the upper, things like that.
Okay.
It feels like a lot, but actually many of these problems were repeated problems.
Yeah.
You don't, but I know it's a lot. I mean, just 2 hours of math. I mean, I don't expect you to go and do another 2 hours, but if you did have some time, it would be good to rework some of the problems we were doing and seeing if you get the same results, try and do them fresh without looking at the answers. But I know there's a lot there.
Yeah.
Hopefully you feel a little better going into the test here tomorrow.